Hello people, this is Department Insta question number 6. Pick the pair whose exotoxins act by ADP ribosylation. A. Clostridium tetani and Bacillus anthracis, Clostridium perfringens and Staphylococcus aureus, Corynebacterium diphtheriae and Escherichia coli, Enterococcus faecalis and Mycobacterium tuberculosis. The second response is the wrong answer. The first response is slightly a wrong answer. The third response is a very wrong answer. The right answer would be option C, Corynebacterium diphtheriae and Escherichia coli. I'll explain you how. If I start with Clostridium tetani, the two major toxins are tetanospasmin and tetanolysin. Where tetanolysin is not involved in clinical feature, it speaks about the lysis it causes on blood agar plate, while spasmin is the one who deals with the mechanism for pathogenesis. Well, spasmin's primary function is to inhibit the release of GABA and glycine, which are inhibitory neurotransmitters, so that they cause consistent contraction, which is called as spastic paralysis. Bacillus anthracis exotoxin has two fractions. One is called as edema factor, the other one is called as lethal factor, which are clinically relevant. The third not clinically relevant factor would be protective antigen fraction. Here, the protective antigen fraction is only immunologically important, while the edema factor and lethal factor are known for causing localized edema with the rim of edema at the central caseous necrosis or non-caseous necrosis. It can cause a particular lesion called as malignant pustule. It is black necrotic area with the rim of edema, and this can also be referred to as eschar. And the mechanism is by activation of cyclic AMP in case of edema factor, and in case of lethal factor, it is by inhibition of MAP kinase. When it comes to Clostridium perfringens, the most important toxin is lecithinase, which breaks the lecithin, a phospholipid. Staphylococcus aureus is the king of many exotoxins, but these exotoxins are not related to ADP ribosylation. Enterococcus faecalis and Mycobacterium tuberculosis are not very known for toxins. Now let's come to Corynebacterium diphtheriae. Here, you will be having the particular toxin of C. diphtheriae called as diphtheria toxin blocking elongation factor 2 in eukaryotic protein synthesis. So, how do they perform the inhibition? They cause ADP ribosylation of the elongation factor 2, because of which elongation of translation is actually blocked. So, protein synthesis in eukaryotes is blocked, so the cells may die. Escherichia coli, when you think about the heat stable toxin or the heat labile toxin, they can act either by cyclic AMP or cyclic GMP. If it is heat labile toxin, it is through cyclic AMP. If it is heat stable toxin, it is through cyclic GMP. They open the chloride channel. What they technically do is the toxin will cause ADP ribosylation of G proteins. The toxin can cause ADP ribosylation of the G protein and keeps the G protein in the continuously active state, because of which chloride channel is continuously open. When the chloride channel is opened, then through the particular channel, a lot of chloride will be lost into the lumen. As chloride is lost, you will lose sodium, which follows it, and sodium is hygroscopic, so water is also lost into the lumen. This is called as loss of water, and electrolytes called as sodium and chloride, which is diarrhea. Thank you.